Welcome to Fact Vault, your one-stop channel for mind-blowing facts and fascinating discoveries. Today we're journeying beyond our planet to explore some of the most unbelievable facts about space. So buckle up and get ready for an incredible ride through the cosmos. First up, let's talk about the mysterious black holes. These cosmic giants have such intense gravity that even light can't escape their pull. Imagine something so powerful that it warps space and time itself. Black holes form when massive stars collapse under their own gravity, and they continue to pull in gas, dust, and even entire stars. The boundary around a black hole, known as the event horizon, is the point of no return. Once something crosses this threshold, it's gone forever. Scientists have discovered supermassive black holes at the centers of galaxies, including our very own Milky Way, with masses equivalent to millions or even billions of suns. Next, let's wrap our heads around the sheer size of the universe. Scientists estimate that the observable universe is about 93 billion light-years in diameter. To put that into perspective, 1 light-year is the distance that light travels in a year, which is about 9.46 trillion kilometers. So, multiply that by 93 billion, and you start to get a sense of just how vast the universe truly is. What's even more mind-blowing is that the universe is still expanding. This expansion was first discovered by Edwin Hubble, who observed that galaxies are moving away from us, with distant galaxies receding faster than those closer to us. This phenomenon is known as the Hubble flow. Ever heard of dark matter and dark energy? Together they make up about 95% of the universe. Yet we can't see or detect them directly, only their effects. It's like knowing ghosts are there because they move things around, but you can't actually see the ghosts. Dark matter doesn't emit, absorb, or reflect light, making it invisible to current scientific instruments. However, we know it's there because of its gravitational effects on visible matter, like stars and galaxies. Dark energy, on the other hand, is thought to be responsible for the accelerated expansion of the universe. It's a mysterious force that counteracts gravity and makes up about 68% of the total energy in the universe. Here's a fascinating one: neutron stars. These are remnants of supernova explosions and are so dense that a sugar cube-sized amount of neutron star material would weigh about 1 billion tons on Earth. Neutron stars are the collapsed cores of massive stars that have exhausted their nuclear fuel. They are incredibly small, with a diameter of just about 20 kilometers, but their mass can be 1.4 times that of the Sun. The extreme density of neutron stars means that their gravity is incredibly strong, making them some of the most compact objects in the universe. Neutron stars can also spin at incredibly high speeds, with some rotating hundreds of times per second, emitting beams of radiation like cosmic lighthouses. Did you know that space is completely silent? Sound needs a medium to travel, and in the vacuum of space, there's no air or other medium to carry sound waves. So, while space may be dazzling, it's eerily silent. Imagine floating in the vast expanse of space, surrounded by stars and galaxies, but hearing absolutely nothing. This silence is because sound waves are mechanical waves that require a medium, like air or water, to travel through. In space, there are very few particles to transmit sound, creating an environment of complete and utter silence. One of the most stunning sights in space is the Pillars of Creation in the Eagle Nebula. These towering columns of gas and dust are star-forming regions captured in breathtaking detail by the Hubble Space Telescope. The Pillars of Creation are part of the Eagle Nebula, located about 7,000 light-years away from Earth. These columns, each several light-years long, are dense regions where new stars are being born. The intense radiation and stellar winds from young massive stars are slowly eroding these pillars, giving them their unique sculpted appearance. The Hubble images of the Pillars of Creation have become iconic, showcasing the beauty and complexity of the universe. Let's talk about exoplanets, planets that orbit stars outside our solar system. Scientists have discovered over 4,000 exoplanets, each with its own unique characteristics. Some are rocky like Earth, while others are gas giants like Jupiter. The search for exoplanets began in earnest in the 1990s, and since then we've found planets in all sorts of configurations, from hot Jupiters that orbit their stars in just a few days to potentially habitable Earth-like planets in the so-called Goldilocks zone, where conditions might be just right for life. The discovery of exoplanets has revolutionized our understanding of the universe and opened up the tantalizing possibility of finding life beyond Earth. Speaking of gas giants, let's not forget about the Great Red Spot on Jupiter. This massive storm has been raging for at least 400 years and is so large that 3 Earths could fit inside it. The Great Red Spot is a high-pressure region in Jupiter's atmosphere that produces anticyclonic storms, meaning they rotate in the opposite direction of hurricanes on Earth. The storm's reddish color is still a mystery, but it may be caused by chemical reactions involving the planet's atmosphere and the solar ultraviolet radiation. Despite its size and power, the Great Red Spot has been shrinking over the past century, and scientists are keenly observing it to understand why. The speed of light is the fastest speed in the universe, clocking in at about 299,192 kilometers per second. To put that in perspective, light from the sun takes just over 8 minutes to reach Earth. This incredible speed means that light can travel around the Earth's equator about 7.5 times in just 1 second. The speed of light is not just a fundamental constant of nature, it's also the ultimate speed limit for any object with mass. According to Einstein's theory of relativity, as an object approaches the speed of light, its mass increases, requiring an infinite amount of energy to reach the speed of light. This makes faster-than-light travel currently impossible according to our understanding of physics. Finally, let's explore the cosmic microwave background, CMB radiation, the afterglow of the Big Bang. This faint microwave radiation fills the universe and provides a snapshot of the universe when it was just 380,000 years old. The CMB is a crucial piece of evidence supporting the Big Bang theory, showing us what the universe looked like in its infancy. Detected by radio telescopes, the CMB is remarkably uniform, with tiny fluctuations that correspond to the seeds of galaxies and large-scale structures we see today. Studying the CMB allows scientists to learn about the early universe's conditions and the fundamental parameters that govern its evolution. From black holes to the vast expanses of the universe, space is full of wonders that boggle the mind and stir the imagination. If you enjoyed this cosmic journey, hit the like button, subscribe to Fact Vault, and turn on notifications so you never miss an adventure. See you next time in the Vault of Knowledge.